All right, so our first lesson for this next, well, for today, our only lesson is 3.1, note linear regression and system. Okay, a linear regression is utilizing a group of information, a group of data points to find an equation and come to a conclusion about the given information. So we're going to start here. So here's our real world table scenario. We have the population for New York City and Los Angeles. And so this is the growth of the population from 1950 to 2000. And so what we're going to do is use a linear regression or create to figure out the best way to represent this information. So what is a linear regression? Well, linear regression models are used to show or predict the relationship between two variables or factors, okay? That's what a linear regression is. So on your paper, we're going to first label our two situations here. So New York and Los Angeles, they're going to be their own equations. So this is going to be our Y1. This is going to be our Y2 data. Okay. And when we are representing the years, we are going to decide how do we want to represent. Do we want to write 1950, 1960, 1970? But we're going to short it. We're going to write it as, we can do the 50s, the 60s, the 70s, 80s, 90s, 100s. But that's not going to work so well. Or we can say 1950 is our 0. And we're going, this is 10 years after the 0. This is 20 years after the 0. This is 30 years. This is 40 years. This is 50 years. Does that make sense? So adjusting it so that you're not dealing with ridiculously large numbers as your X values. So this is our X. Now the next question is there a shorter way for us to represent the millions of people? Huh? What'd you say? Yeah, so we can write it as, was that scientific notation, right? But without the times 10 to the whatever. So if we write this in scientific notation, instead of 12,911,000, this would be 12.9 million. Does that make sense? This would be 4.4 million. This would be 6.7 million. This would be 14.8 million, 7.0 million, 16.2 million, 16.1 million, 11.5 million, 18 million, 14.5 million, 21.1 million, 16.4 million. How do you feel about using those numbers instead of having to write everything completely out? Make sense? Now, if you wanted to write it as is, would I stop you? No, I would just stare at you wondering why you want to type so much. So when you're given a large set of data, you can minimize the amount of digits you have to type by rounding. All right, are you ready? Yes, no? Okay. So we're going to be using the Desmos graphing to conclude all of this. So we're going to follow these steps. We're going to fill in the information as we follow it, and hopefully you guys see that it's not terrible. So off to Desmos we go. I'm going to start a new graph. I need a new blank graph. So I'm going to start a new blank graph. And I'm going to follow these steps. So start a new blank graph. I did. Then it says I'm going to create a table. So to create a table, I press the plus, and you see where it says table. I select table. I'm going to input the additional column by typing Y2. I'm following the steps. I started with Desmos, started a new blank graph, created a table. So we just did step. And we decided that we can represent our years by having 1950 be our 0, and then counting by tens, right? And then we decided we're going to shorter way of writing the millions is using an abbreviated form of scientific notation. So we're going to input those values as so. So our X values are 0, 10, 20, 30, 40, 50. And we're going to put in the values for Y1. That's 12.9. Y1 is our New York, so 14.8, 16.2, 16.1, 18.1, and 21.2. So those are the values for New York. Then we're going to put in the values for Los Angeles. 4.4, 6.7, 7.0, 11.5, 14.5, 16.4. Okay, so we've done steps 1, 2, and 3. If you're not following along, this is definitely something you have to practice in order to be able to do. Are we all at steps complete 1, 2, and 3? All right, so we're going to move on to step 4. So step 4, it says find the regression model and input box 2. So we're going to go to box 2. So we're going to type, as you can see on your paper, we're going to type 1, but Y1, and we're going to use the Inye symbol, which is the next to 1, MX1 plus B. Okay, so we can't see. So remember we talked about yesterday having to move our graph and zoom in and zooming out to see our values. So we're going to zoom out. You see the line and our points. So these green dots represent our actual value. The red line represents our approximated line that will satisfy most of them. If you look over here, it tells us our slope. So what does it say our slope is? We're going to round to the nearest hundreds. 0 and 1500ths. Our y-intercept is at 12 and 89. And so we write our equation. Let me go back to the. So here, we have $12 and 89/100. So our linear equation is 1y equals 15/100 times x plus 12 and 89/100. Okay, how do we feel? Okay, we're gonna do the second one. So following these steps, we're going to now we're gonna go to box 3. And this time we're typing y2, the NEA symbol, mx1 plus b. So exactly how it's written in your notes. And so the purple dots represent our original points. The blue line represents our estimated equation. And from there, we have our m and our b. So rounding our m to our nearest hundredths, what do we get? 25/100. And then our y-intercept rounded to the nearest hundred is 3.80. Okay. So putting it all together, we have 25, 3.80. So our y2 equals 25/100 times x plus 3.8. And we're trying to see when will they have the same value. So on step 5, we're gonna have to zoom out until we see where the two points, well, two lines cross each other, and at what point that is. Perfect. So again, all you have to do, it was pretty easy, right? Zoom out, and bam. You see the point of intersection, you click on it. Do we all see it? Did we all get the same thing? Okay. So our answer here. So we end up with 86, 84, 25.6. So the question is, what does this mean in regards to the problem? What does the 86 and 84/100 represent? What did our x represent? What did our x represent? That's our years after 1950, right? So those are our years after 1950. Let me write years a little prettier. So those are our years after 1950. And what does the 25.6 represent? The population in what? Millions. Okay, so this is not the answer. This is the point of intersection. The answer comes from us explaining what each part represents. So we would write, what is 86 years after 1950? Well, let's do it. 1950 plus 86, which is basically 87. Let's round it up. 7, 3, carry, regroup my 1. So in 2037, the population of, is it New York and LA? Of NYC and LA will be both 25.6 million. Huh? Mm-hmm. So that's our estimation based on our regression. The earthquake? Mm-hmm. Oh, we fine. All right. How was it? How was the linear regression? Okay. We're going to do another one together. So linear, this is really utilized for real world situations. So here we go. We have, the table shows the winning times for the Olympic 400-meter dash. Using your graphing calculator to find linear models for women's and men's winning times, assuming the trends in the table continue. When will the women's winning time and the men's winning time be equal? And what will that winning time be? Okay, so again, we're going to establish what's our X, our years. And we got to decide what are we going to count by. If we, by fours? Is it fours? It looks like it, yeah. So we're counting by fours, 0, 4, 8, 12, 16, 20, 24. I was like, what comes after that? 28 and 32. So those are our X's. And then our times, they're pretty easy, right? It's already short numbers. So this is our Y1 and this is our Y2. Okay, so we're going to do this one together and then you're going to do one on your own. Cool? So I go back to Desmos. I'm going to start a new blank graph. I'm going to add a table. I'm going to add a Y2. And then we are counting by fours. 0, 4. And then I love that it just keeps counting it by for us. As long as you establish what you're counting by. You just hit enter and it fills it in. And then we put in our values. So we're going to do the men's, which is our Y1. They have 43, 46, 44, 66, 4426, 4460, 4427, 4387, 4350, 4349, 4384. And then we have our women, 52, 51. If you ever take a stats class, you're actually gonna learn how to do this completely by hand. I know that sounds exciting, right? Nobody is excited about that in stats? You are the human calculator. I forgot, I think I skipped one. Oh, dang it, where did I skip it at? All right. 52, 51, 49, 48, 48, 83. And then oh, there was two 4883s. That's what threw me off. The numbers are on your paper. On the back side. All right. Got all my values. Are we all good? Is it going well on the phone app? Okay. Okay, so remember you're typing in y1 and you're not equal, you're using the inye symbol. mx1, that's because you want to use the values in x1 plus b. Because this isn't a variation problem, it's a linear regression. So we want to make sure we put the plus b. We're going to do a little zooming out. Now, for running, isn't it a good thing that the times are decreasing? Yeah, because the goal is to get faster, right? So it's a good thing that it has a negative slope because the goal is to get faster. So our m equals negative 0.02 and our b equals 44.28. So our y1 equals negative 0.02 x plus 44.28. Let me write it down. So for y1, we have negative . Okay, now we're going to find our y2. So to find our y2, we're typing y2 mx1 plus b. And again, a decreasing slope. Awesome. So our m equals negative 0.09. Our b equals 50.86. So our y2 equals negative 900 x plus 50 and 8600. Okay, so we have our y2 equals negative 900x plus 50 and 8600. All right, the question is asking us, when will the women's timing and the men's winning time be equal? So what are we going to do? Zoom out. We're going to zoom out and look for the intersection, right? So we're going to zoom out and look for the intersection. Bam. Fairly quickly. So we zoomed out, we found our intersection. So what does our intersection mean? What is this? What does the 92.5 mean? Years, right? So years from 1968, right? So we have our intersection, but we got to pertain to what it means. Uh-oh. Uh-oh. Yeah. There we go. Yeah. All right. So this means that we got 90 Let's round it up to, well, 92.5, and the time would be 42.64. So it asks, when will the women's winning time? Well, when means that I'm going to have to add 92 to 1968, right? So I have to do 1968 plus 92 and a half. So the times will be equal in the year of 2060 and a half. And the speed will be, and the winning time will be, the time is 42.64 seconds. Okay, so again, see how the intersection is not the answer, it leads you to the answer. So if you just told me 92.5, you only receive partial credit because it's not what they're asking you. It asks them, when will it be? Okay, how do we feel? Well, the last one is for you to try on your own, completely flying solo. Let me know if you need help, but it's pretty much exactly what we just did, but just making sure you're comfortable going through the steps and inputting the data on your own, okay?